In the previous videos of this unit, we learned about the measures of center, mean, and the measures of variation, such as standard deviation. Those are just the two. We know there's more. But what's the significance of those and how are we going to use it? So basically, those measurements help us to reconstruct the shape of the distribution somewhat. We're going to use, of course, the center of the data, and we're going to use the standard deviation as a measuring stick. So to break our distribution into portions. So for example, if I knew that I have a distribution with a mean of 50 and the standard deviation of 10, I could represent it in this way. So 50 is the center of the data, and then 10 is my unit step. So one standard deviation to the right would be, this is mu plus sigma. So it's going to be 50 plus 10, that's going to be 60. And then if I go one standard deviation in the opposite direction, that's going to be mu minus sigma. So 50 minus 10 or 40. Okay, so now I can also do one more step to the right. So this is going to be mu plus 2 standard deviation, or 50 plus 2 times 10, and that will give me 70. And one standard deviation to the left will give me mu minus 2 steps, or 2 standard deviations. So that's 50 minus 2 times 10. That gives me 30. So I have it. If I have if I step one standard deviation to the left from the mean, I get to 40. If I step one standard deviation to the right, I get 60. Two standard deviations to the left, 30. Two standard deviations to the right, 70. Let's do one more step. So mu plus 3 standard deviations. So that's going to be 50 plus 3 times 10. So that gives me 80. And one more step into the left direction to the left will give me 50 minus 3 times 10, or 20. So we can divide our number line like that. And there was a Russian mathematician. His last name was Chebyshev. Chebyshev, who came up with this rule that will say that if we look at any data set, then we're gonna have a certain amount of data within one standard deviation from the mean, right here. So in our case, from 40, between 40 and 60, we're going to have a certain percentage. And that percentage is at least 75%. So at least 75% of the data is going to be within one standard deviation. Now, if we move away from the center to 2 standard deviations to the left and 2 standard deviations to the right, in this interval, we're going to have at least 88.89%. So at least 88.89%. So for this specific distribution, with a mean of 50 and standard deviation of 10, at least approximately 89% of data will be between the values of 30 and 70. And if we step out even more to 3 standard deviations away from the center of this distribution, then we're going to have at least 93.75% of the data between those values. And the values are between 20 and 80. So that's the significance of the measuring stick, so to speak, or standard deviation. Let's take a look at this example. It reads, if we know the IQ scores of a group of 112 children have a mean of 104.5, so the mean of our distribution is 104.5, and the standard deviation of 16.3. Find one standard deviations above and below the mean and two standard deviations above and below the mean. I'd like you to stop the video here and try to do it by yourself and then compare the results with mine. So go ahead and pause the video. So are you ready? Let's compare our results. So I marked the center of my data, 104.5, and then one standard deviation to the right will give me 120.8. One standard deviations to the left, 88.2. Two standard deviations to the right will give me 137.1, and two standard deviations to the left will give me 71.9. And again, according to the Chebyshev's rule, I know that at least 75% of the data are going to be between 88.2 and 120.8, and at least approximately 89% of the data will be between 71.9 and 137.1. Now, if we were to superimpose a histogram on this chart, we would get about about 75% right here between these two values. So at least 75% right here, and then we would get 14 more percent on the sides right here. So this about 7% on this side and the 7% on this side, making it 89% altogether. Again, this is a rough idea, rough estimate of what the histogram would look like. In a reality, it doesn't have to be symmetric. It could be skewed. It could be a different shape, basically, not necessarily symmetric. And the Chebyshev states the least percentages, which meaning that it could be more than 75 in reality, but it's no less than 75%. The beauty of Chebyshev's theorem is that it works always. It works for all kinds of distribution. And here's the Chebyshev's rule in its entirety. Not only we could figure out the percentage between one standard deviation or two standard deviations, three standard deviations away from the mean, we can figure out the percentage of data using any number of standard deviations, like 1.5, 0.6. And the Chebyshev's rule says that regardless of the distribution, the percentage of the data that falls within a certain number of standard deviations of the mean is at least 100 multiplied by 1 minus 1 over k squared where K is the number of standard deviations away from the mean. Okay, we're not gonna focus too much on this rule. I just want to let you know that it's out there. And but let's move on to our next slide because it brings out some significant definitions for us. The first is the rule of thumb or 3 standard deviations rule. It says most of the observations in any data set lie within 3 standard deviations to either side of the mean. Anything beyond the 3 standard deviations is considered to be very unlikely and therefore satisfies the definition of an outlier. So all the outliers are beyond 3 standard deviations from the mean. In some books, the values that are more than 2 standard deviations away from the mean are called significant values or unusual values that are either significantly low or significantly high, depending on whether they are below or above the mean. So if let's take a look at our picture again and discuss this rule of thumb. So if this is our distribution, then everything that may lie outside 3 standard deviations right here. So these values are going to be outliers. And anything that falls in this area between 2 standard deviations and away, 2 standard deviations and below. Actually, yeah, this is 2 standard deviations. Okay. Sorry, the outliers, I didn't notice that this is 3 standard deviations. This is 2 standard deviations. So the outlier would start here, the outlier zone, beyond the 3 standard deviations. So this is the outlier zone. Now, anything 2 standard deviations away. So this zone, this is the zone of unusual values. So these are unusual values or significant values. So that's what that the rule of thumb means. Again, I want to remind you that the Chebyshev's rule works for any distribution of any shape. In the next video, we're going to talk about a specific distribution, which is called a normal or bell-shaped distribution.